All right, our final lecture. The final section we're covering, this is on hyperbolas. Hyperbolas are very similar in setup to ellipses, at least equation-wise, and all the steps we're going to take. The graphs are drastically different. So, just like ellipses, we are going to have an x minus a squared, we are going to have a y minus k squared, we are going to have an a squared on bottom, we are going to have a b squared on the bottom. It's going to equal 1. But there's a minus between them. There's 2 setups. The other setup is when y is the positive 1 and the x thing is the negative 1. So this is an or situation. One of these configurations is going to happen. Whichever one is positive tells you it's not called the major axis in this. For hyperbolas, major axis is the equivalent in hyperbolas is called the transverse axis. So I'm going to call this A, and I'm going to call this B, and I'm going to graph them below. I should have done them separately and did a little bit better. It's helpful to think of this as hyperbolas are like twin parabolas opening in different directions or opposite directions along the transverse axis. So before I dive into the details, just to give you a picture of what's going on here. A's setup and B's setup here. And both of these will be centered at the origin. When X is positive, the positive term, and Y is the negative term, we're going to have something that looks like this. This is the general shape. We'll dive into the details of how you draw it and get all that in a second. That's what I mean by parabolas opening in the direction of the main transverse axis. So in this case, the transverse axis, that's their transverse axis. For B, the transverse axis is up and down. And so our parabolas will open in that direction. They look like twin parabolas. They're not parabolas, but they look like it. The Gateway Arch in St. Louis, Missouri. You guys all know what I'm talking about. You've seen pictures of it before. I can like load the computer up and show you, but it's a giant structure that looks like this. It's enormous. It's like fucking 30 stories tall or some shit like that. I don't know how tall the Gateway Arch is, but it is. It's the bottom half of a hyperbola. Yeah.
Do the twin parabolas of the hyperbola, do they go on into infinity?
Yes. I put arrows along this one. I did not put arrows along this one. I should have. And they're not really parabolas. You're going to see how they're different in a second. They look like parabolas.
Can you put the paper down just a teeny tiny bit for a second? Thank you. That's all I need.
All good?
All good. Thank you.
Okay. I didn't tell you guys the other fun thing that ellipses do. So ellipses, the foci on ellipses, look up Whispering Gallery later on. Quick deviation for ellipses. Look up Whispering Galleries. Independence Hall in Philadelphia was.
Is that like the thing where you be standing in one side of the room and on the other side?
Yes.
And it's just those two places.
It's just at the foci.
They have one like that in, I think it's like at the,
There's a,
was it the Four Corners place where they have, you can stand all the way across, or maybe in Arizona, which is in the, it's like a whole park and you can just.
I haven't seen one in a park. That would be super cool. Independence Hall has one if you visit. This is gonna sound weird, but if you visit the Supreme Court in DC, like near the Supreme Court is where the Congressional Hall used to be. They have a Whispering Gallery in there. The original one in Independence Hall, Ben Franklin understood the fucking rules of ellipses. He put his desk at one of the foci and never spoke while he was at it. Ever, because he knew what would happen. And he put his people that were on the other political side. He put the major speaker's desk at one of the foci, or at least one of it. He either got lucky or he placed the desk there. He would just eavesdrop on what the other people were doing, what their strategies were to try to win the politics of the day. Because he knew how Whispering Galleries worked. And the principle is any sound emitted at the foci of one, doesn't matter how silent it is, you can whisper it. Since it's shooting out and hitting everything on the ellipse, and it's all fucking focus firing on the other parabola or the other foci, all those sound waves converge and you can perfectly hear the person. Literally, it sounds like regular sound. It's super cool. Look that up. All right, back to hyperbolas. Okay, so let's look at. It's going to work for both of them. Let's start with this one right here. How do we go about drawing an ellipse? So what you want to do is you want to figure out how far out A is and put it just like you're doing an ellipse, put points there. Just like you're doing an ellipse, A and negative A. This is centered at the origin. And I'll put B here and negative B down here. Notice the A and the B, A could be larger or B can be larger, but the ellipse always opens in the positive one. So sometimes the ellipse is not opening along the bigger number. It's just opening along whatever character it is. Okay, so what you want to do here is you want to make a box. What I mean by make a box is make little dotted lines over. And come down. You don't actually need to draw the box. The important thing are these four things. The corners of that box is what you really want. Corners of the box. So you don't need to put the little black dotted lines if you don't want them. I'm doing that to show you what the hell I was doing. In fact, it's better without the black lines. Because what we are going to do with those corners is the corners make up 2 points on an asymptote. We will have an asymptotic line going through these corners. And I will have an asymptotic line going through these corners. So these are asymptotes. Can anyone figure out what the slope or the equation of this line is by looking at it? Taking advantage of slope and y-intercept?
They just cross at the origin, right?
They cross at the origin, so my
There's-
y-intercept is 0.
So it's just 1/1.
It's not 1/1, it's b or a.
Oh,
So in this one, we have y equals plus or minus b over ax. These are asymptotes. And even though I think the program, I hope the book doesn't switch the b's and the a's for the x's and y's. I always keep the b with the y and the a with the x. So this will always be the asymptotes, no matter which hyperbola we're doing. Now, what you do is, once you have those asymptotes, this is a vertex and this is a vertex right there. They are along, the vertices are along the transverse axis. And this, the transverse axis here is the x-axis, because the x minus h squared thing is greater than 0. It's the positive term. Now, this is where you don't want to be too sloppy, but you're really just making something that looks like a parabola that goes to follow along the asymptotes. The foci again are at plus or minus C along that axis. But C's calculation is slightly different. C squared equals A squared plus B squared. Which is funny because the ellipse, this has a negative sign in the equation, but the C has a positive. In the ellipse, it's the other way around. The equation has the positive and the C squared has the negative. This actually looks like the Pythagorean formula, right? In fact, it is. This distance right here is C, and that's how far, oh, that's a good way of doing it. Like figure like swinging that down like that. I will have a foci right there. And a foci right there. Starbucks has a new white chocolate macadamia cream cold brew. And while it was tasted good, I didn't taste macadamia nut or white chocolate.
There's too much stuff today, it's all things for me.
Some disappointment. Oh, and eccentricity follows the same pattern as ellipses, which is nice. Eccentricity is, I found a better way of saying it than I did the other day. Thought of it today. C over the max of A and B. There we go. Whichever one is the larger number, that's the one that goes on bottom. It's the same as the ellipse setup, but C is always further out than A or B. So this is always bigger than 1. We're going to do the other one that opens up next. Not very much of this changes. At least most of the steps don't change. Let's take a look at the other one, the form of y minus k squared over b squared minus x minus h squared over a squared equals 1. Again, for simplicities, in graphing, doing this initial one, I'm going to set for this graph, HK will be at 0, 0 for this graph. Now here, I definitely deliberately skewed it so that you could see that A can be bigger than B, and it still doesn't mean that that's the axis that you're worried about. The axis, the transverse axis is always the positive one. So transverse axis here is the y-axis. So this is going to open up and down. Yeah.
We know that it's the y-axis because the y variable.
Because the y variable is the positive one, yes. Whichever one doesn't have the negative sign in front of it. Whichever one doesn't have the negative sign in front. I'm just specifically stating it like that because sometimes the book will like to put this. This is the same equation as, let me write it down here. I could do negative x minus h squared over a squared plus y minus k squared over b squared equals 1. And this is the same equation. I've just switched the terms around. The positive one and the negative one. We wanted the transverse axis to be on the positive one. We are going to make our box. I'm going to do it without doing those dotted lines now, though. And you kind of want it kind of hard when they're far away from the center to do that. If you have a ruler, it helps. I need to rotate this page so I can draw this one. I'll put it back in a second. It almost helps to start at the center and go outwards towards them. There we go. Here, my vertices are at these locations. My C will be somewhere along that axis somewhere. My foci will be somewhere out there. And now this goes asymptotically towards those two. So the way I did it, this is a very wide and flat looking hyperbola. Again, if you keep this format, these asymptotes are at y equals plus or minus b over a x. At least until you shift along HK. Having a general formula, I guess I could figure out a general formula for it. It might just be plugging in y minus k and x minus h, but I don't think it is. I don't think it's that fucking easy. So c squared is, I didn't write down, but maybe I should. C squared is still for this one a squared plus b squared. And eccentricity is still c over the max of a and b. You guys ready to look at some actual examples? All right, let's graph x squared over 4 minus y squared over 25 equals 1. Sketch the asymptotes. Find the coordinates of the vertices and the foci. Vertices is plural of vertex. And foci is plural of focus. And why not? Let's do domain and range also. I recommend when you get started, just identify which way, where your transverse axis is and what it's going to look like. My x squared is the positive one. If the parabolas or things are going to open along x, I just draw a little tiny picture to remind myself later on of what that's going to look like. Because it's easy to forget later on, especially like if, in this case, the B is much bigger than the A. When you're doing it with the ellipsis, you're so used to using the major axis as the long one. And the long one does not correlate to which way it opens. So it's worth it definitely with the hyperbolas sketching left or right or up and down. So what is my A and B here? Two and five, yeah. I'm going to pencil in my vertices right now. I know they're along the major axis or the transverse axis. And they're right there. Those are my vertices. And I can see from the picture, the vertices are at plus or minus 2, 0. So I put in my corners for my asymptote. I'm just going to sketch them. These are y equals plus or minus b over a, which is 5 over 2x. Those are the asymptotes lines. And now my hyperbola is just gonna go towards them. I want to determine my foci. C squared equals a squared plus b squared, which is 4 and 25. Just the numbers right underneath the x squared and y squared. So c squared is 29 and c equals the square root of 29. which is about, I don't know, 5.4, maybe 5.3. 5.35 maybe. Let's be honest, when you're graphing them, as long as you get the foci somewhere between 5 and 6, realistically, you're fine. So this is 2, 3, 4, 5, 6. And my foci are right about there. You guys ready for, oh, you gotta do more. So the foci are at plus or minus square root of 29, comma 0. That's the accurate answer. You only want to use this to really approximate or figure out where you're putting it on the graph. What's the domain and range here?
-2 bracket union 2 2.
Yep, that is the domain. We go left to right, there's nothing between -2 and 2, but we have everywhere else. The range is, of course, negative infinity to infinity or all real numbers. What about eccentricity? Let's do that. I didn't mention it above. C over the max of A and B. Which is root 29 over 5. My bad. It is not, I fucking said the wrong thing. It is not C over max. It is C over the positive one. Eccentricity E is C over how do I say this? The Yeah, I'm just gonna say the positive one. I mean, a squared and b squared are both positive, but I think that, so in this case, it's the over the x. So this is the over the x-axis on this one, which is gonna be a.
If this is the same as it is, but
Ellipse is the max one.
so there is a difference.
I guess. No. I guess not. Because the transverse axis. The eccentricity is that's a good one to go, way to think of it. It's over the one associated with the transverse or major axis. So if we look at it for both ellipse and a matrix, it's the letter with the major or transverse axis.
Last week you had us have it be eccentricity is C over.
Yeah, the major axis is 2a. Yeah, so it's going to be over a or b. Needs to be a nice way to do this. This is why they changed the A, what letters over the A and the B underneath the X and the Y. It fucks up every other equation. Like it makes it like you'll have X squared over B squared in the book. Like that's not how, that's fucking confusing having the B's and A switches. The only problem is that is on the E. You have to like remember how the thing on the bottom works. And with their approach, it's always consistent. Their eccentricity equation is easy, but every other fucking equation is hard. All right, you guys ready for another one?
So even the square root of 29 is 2.
Square root of 29 over 2, yes. You guys ready for another? All right. Let's do all the same shit. We're gonna graph asymptotes. We'll find the vertices, the foci, eccentricity, domain and range of (16y squared minus 25x squared equals 400). Now you may well look at it and go, what the hell do we do? So a pro tip, when you see both x squared and y squared, you have two options. If the coefficients are the same. Divide it out. And this is gonna make a circle. You'll end up with x squared plus y squared equals r squared. If they are different, if the coefficients are different, divide by the right side. I'm going to say the other side. Which hopefully is your constant term. And this will lead to either an ellipse, if they have a plus between them, or it'll be a hyperbola if there is a minus in there. Because we did a setup like this with the ellipse where we had coefficients on them and we divided. All right, so in this case, I have a y squared and an x squared, they're both squared. I have a minus sign between them, which tells me this is a hyperbola. I want a 1 on the right, so I'm going to divide everything by 400. My y is the positive 1. It's gonna look like that. It's gonna open up and down. What's my A and my B? Yep. 4 and 5. Which means this is almost gonna look like a square, not a rectangle for my asymptote box. So going from the center, I will draw my asymptotes. So I know it's opening up and down, and it's gonna veer towards the asymptotes. God, that doesn't look very good. Maybe you can do it a little bit more like that. I don't know. Again, it's a sketch. As long as I don't make it look like a diamond or a point, it should be curved. So we'll give you like 0 points on the test if you make a fucking diamond rather than a circle and an ellipse and those problems. Yeah,
So the first term is the A in this one?
the A is always underneath the X. They don't look like evenly spaced, do they? I think I may maybe hashtags along X wider than I did on the Y. It's a sketch. If you want it exact, you use a graphing calculator or computer. Where are my vertices?
Zero plus or minus 5.
0 plus or minus 5. They are the points along the transverse axis. Foci. How do I get the foci?
C squared equals.
C squared equals A squared plus B squared, which is 16 plus 25. So C squared equals 41. And C equals the square root of 41. Which is 36 would be 6 and 49 would be 7. It's closer to 6 than 7, but it's probably 6.45-ish or so. I don't know, something like that. But we're going to use the square root of 41. It's also along the Y. So we're going to have that. My eccentricity here is that square root of 41, my C, over the major / transverse axis value, which is in this case, the y-axis has a 5. And if I wanted to plot my foci, I need to go up, at least draw a couple more lines going up, down, and put them in there. What's the domain and range? Domain is all real numbers, or if you want to do negative infinity to infinity. What about the range?
Range is negative 2, negative 5. Bracket is union. Bracket positive 5.
Yep. Excellent. All right, you guys ready for more? Nope, I see several pencils moving. Slow your shit down. All right, now let's we're gonna move it away from the origin. So let's do x minus 2 squared over 16 minus y plus 4 squared equals 1. Yeah, we'll do the usual. So. Which way is this opening? Up and down or left and right? Why? Correct. Should be going left and right. What is A and what is B? Yep. If you don't see a fraction, you can always make a fraction by putting it over 1. And I can see by looking at it, if I add those two together, I get 17. So C should be the square root of 17. Or 16 plus 1. Which isn't a very big number. It's like maybe 4.1. 4.1 to 4.2. Somewhere close to 4. All right, so where is my center? Two, -4. Excellent. So I knew a lot of my work is in the right and bottom quadrant. Since I know that, I'll do more of my graph focusing on the right and bottom quadrant. Okay, I'm going to drop my center down. 2, -4 is right there. We are opening left and right, and A is 4. I need to go 4 left and 4 right to make my vertices. I'm only going up and down 1 though for my asymptote box. So they open left and right. You said that above, and I follow the asymptotes, which means this is very narrow, isn't it? Where are my vertices at? Now you can do the route like finding them on the graph and calculating the position. Or remember they start at HK and there's C away from it along the transverse axis. The transverse axis is left and right, so it's gonna be plus or minus C here. So if I do that, C is not C, A. So I'm gonna have 2 plus 4 and 2 minus 4. I'm gonna have 6 comma negative 4 and negative 2 comma negative 4. That's my vertices. And if I look at my graph, I can see that is actually where I have them. Foci do the same thing, but now it's plus or minus C. Again, it's always along that transverse axis. So this is, we have one at 2 plus square root of 17, comma negative 4, and 2 minus square root of 17, comma negative 4. I don't know that that's all that helpful for graphing. So in terms of graphing, this is about 4. We already, he said 4.12. So 2 plus 4.12. This one is about 4 or 6.12, comma negative 4. And we've got negative 2.12, comma negative 4. So just barely past it. What's the eccentricity here? Do I put it over A or over B? Over A. Which means it's square root of 17 over 4. What's the domain and the range? Yes. Excellent. And the range? A real numbers, or if you like writing the parentheses, you're going to continue positive. Yeah,
On the exam, should we just write down both?
no, you can write down either one. If we wanted the asymptote equations, I have notes here of what it is when it's shifted. I didn't want to speculate earlier and I didn't remember because this is something I don't do that often. The base situation, the way we have it is y equals plus or minus b over a x. When we shift to hk, these get shifted to hk. Y minus k equals plus or minus b over a times x minus h in parentheses. So for this problem, that is y plus 4 equals plus or minus 1/4 x minus 2. Those will be the equations of the asymptotes. This semester's so close to over. You're almost there. Our final is in 1 week. You'll have finals for the rest of the probably, I have my final right before finals week starts,
Is the final on this next Tuesday or next Thursday?
next Tuesday. I think our actual final allotted time is Thursday, and if you want to come in and look and see how you did, I'll have them graded by then. Which means I'm gonna be a busy mofo on Wednesday. Because I have to take a class after that. I'll probably be grading your guys's in the next class that I have stats after this. Finals. I do have. You can start at 2 if you want. Because 2 to 3 is the support course hour. So if you're here at 2, you can have until 5. It's designed to be done in 2 hours, under 2 hours, really. Hopefully it takes you less than 2 hours if you've been doing your homework and practice and stuff. All right, so something neat to point out before we do another fun example. When the hyperbolas are narrow, or like that. E is close to 1, it's just a hair greater than 1. E is greater than 1, but not by much. It's close to 1. And the foci are close to the vertex. And when they're narrow or wider, the foci are farther away. And E is not close to 1. So quite a bit larger than 1. Oh, this is something you may not know. In mathematics notation, that means greater than. Of course, you knew that one. That one you did know. But when you see 2 of them, it means much greater than. And if you see 2 like that, it means much less than. Now, what that means in terms of hyperbola, it depends. It generally for hyperbola, it means the eccentricity is probably, if the wider it gets, like 10, 15, 20, something like that. What did we have earlier on one of these? Something over the square or something over 2? Square root of 29 over 2 was like almost 3, and look how far away the foci and how wide it looks. So let's do one more example. Where they make it crappy. One of those, find the equation. If E equals 3 and we have foci at -2, 5 and -2, -3. Ooh. Ooh. So once you write that down, I'll give you a nice little strategy to follow with this. Okay, remember what we're trying to fill in. Well, first off, do a little sketch of the information you got. That's the only information we got other than the eccentricity. Do I have parabolas opening up and down or left and right? Up and down, why? You're right, but why?
Because. like,
The foci sit in like the cup, right? So I don't know where it's gonna hit, but I know it's something like this. Which means I should be looking for an equation of the form y minus k squared over b squared minus x minus h squared over a squared equals 1. That's what we're looking for. We need to find hk, and we need to find a and b. So that gives me a place to start. It tells me E equals 3 here, but what is the equation for E? For this problem? It's C over what? It's C over B because we're going up and down, right? And I know that equals 3. Do I know what C is? Can I find C? Maybe it will help if we find the center first, right? I know the center's got to be along that x equals -2 line. That's got to have a -2 in it because the foci are along it. I am trying to find the midpoint along this. If you all don't remember the equation for a midpoint, put it down here. Midpoint is x1 plus x2 over 2, y1 plus y2 over 2. -4/2 and 2/2, which is -2, -2, 1. And the midpoint between the foci is the center. So that just gave you my H and my K. Just by finding the midpoint. So midpoint of foci equals HK. With that piece of information, can I find C? Conveniently, this doesn't change between ellipses and hyperbolas. How far away is the foci from the center? In general, not for this problem, but in general. It's always C away. The foci is always C away. C units from center. So let's just count them. One, two, three, four. If I go downward, 1, 2, 3, 4. In both cases, that distance is 4. So C equals 4. Which means I can put that into my eccentricity equation. So can I find B now? I could clear the fractions. If I clear the fractions, I get 4 equals 3B. And I divide by 3, and I get B equals 4/3. Well, now I've got my K, I've got my H, I've got my B. All I need is my A. How can I find my A? Yes, we have an equation that has A in it. Let's use it. C squared equals A squared plus B squared. Let's plug in what we got. We know C is 4. So 4 squared equals A squared plus 4/3 squared. Well, that's not going to be all that pleasant, is it? I've got 16 equals A squared plus 16/9. What is 9 times 16? 90 and 54 is 144. Holy shit. So if I multiply through by 9, I got 144 equals 9A squared plus 16. I hate trying to work with fractions. We're gonna end up with a fraction. There's no avoiding this. But I think this problem is easier to solve if we don't work with fractions by multiplying through by the 9. If I subtract 16 over, I've got 9a squared equals 144 minus 16, which is 128. Now I'll divide by the 9. And I'll take the square root. A equals the square root of 128 over square root of 9 is 3. 128 is 64 times 2. Which means this is effectively A equals 8 root 2 over 3. I don't know how helpful that is. What I actually really need for this equation is a squared and b squared. So I don't need to worry about this so much. I just need that 128 over 9. So a squared, before I took the square root, a squared here was 128 over 9. And I got my b squared right there. B squared is 16 over 9. So we can put all this together. Let's just rewrite my base, remind you guys what we're filling in. Y minus k squared over b squared minus x minus h squared over a squared equals 1. And we had hk is -2, 1. We have a squared is 128 over 9. And b squared is 16 over 9. We did a lot of work to get those values. We're going to plug them in and show you how to clean it up a little bit. If I plug it in, I have y minus 1 squared over 16 over 9 minus x minus -2, which is going to end up being a +2 over 128 over 9 equals 1. This might help you see how this simplifies. This is ugly. I don't like mixed fractions and fractions like that. If I multiply this by 9 over 1 and 9 over 1, I'm really just multiplying by 1, right? I'm going to do this over here too. The 9s on bottom cancel. And I'm just left with 16 on bottom. And I have a 9 on top. Same thing happens here. The 9s cancel on bottom. I'm left with 128 on bottom. And I have a 9 over 1 on top, which is just 9 times x plus 2 squared equals 1. So that's the answer. The easier way to get there, when you have that, just take this and move it up here. That's really what it is. This is just showing mathematically how you do it without multiplying through by everything by it. Is there any questions on that? Was that super fun or what? Is that everything you hoped it would be? All right, that's all I got for you. That's it. That's the content of this class. There are 10 questions on the final. There's a practice exam up on, it's in Canvas, it's on announcements. it will have a parabola, it will have an ellipse, it will have a hyperbola on it. So I recommend trying to do at least some of the homework from each section, get chapter 12 done as much as you can, or what chapter are we in? 10. Get as much of chapter 10 done as you can before you try it. I recommend giving that practice exam a try before you come in on Thursday. Because then you'll know exactly what you don't remember how to do and what you need to focus on. We're gonna enter stuff on there from the logarithm sections, the exponentials. We had even the whole synthetic division was in this section. There's been a lot of shit since then. But what you see on the final exam or practice final exam are the same types of questions I'm asking on the final exam. I don't give practice exams where I say, here, I want you to study this, and then I go, nope, finals on completely different shit, you're fucked. No, that's never seemed like a good idea. A practice exam should tell you what I think is the most important, or at least what covers everything in the class. I could do it in 20 or 30 questions, but for the time frame, these will work. There's 10 questions. There will be at least one extra credit question. There might be 2. And I won't tell you what those are, but I think I've talked about them in class when I was enjoying this particular section more than others. Other than that, yeah.
Sorry, this upcoming Thursday is you want us to do the exam for this Thursday too?
I recommend at least going through it and doing all of the non-chapter 10 ones. Because the other stuff it's been a little while since we've taken the midterm. So you might go through it and see what you do. Go through your notes first. Like just skim your notes, look at what you did. Remind yourself how to do logarithms, exponentials, shit like that, because it's been a while. Glance over synthetic division, finding, remember the whole P over Q? Finding, oh yeah, all possible rational roots. Yeah.
And then on Thursday of the day,
We'll walk through them all. But if you've taken it before then, you'll know what your hard spots are. Like if you're like, oh, synthetic division was fucking easy. I liked it when we did it. So I don't think anyone's saying that in this class, but you might be thinking about logarithms or something. Other than that, we're done. Fuck out. Unless you've got questions. Class isn't technically over for another 25 minutes.